Hi everyone. Today we are going to do modal analysis on a cylinder on Ansys. So the first step is to be here on the toolbox and you take the model. Okay. So this is the one that you use because we are going to looking for the natural mode. So you need to take the model block. So now we're fine. You can even right click here or double click and start writing what you want. For example, modal analysis on a cylinder. Okay, so you can do this. So this is fine. Now for the geometry, because you can see I didn't import, so let's go to geometry, right click. So you have three different way of creating geometry. You first have the new discovery, you have the space claiming, the design modeler. Design modeler is really cool. You have so many options of creating your geometry, but I prefer the space cam because I have usually I use the space cam and I really like the space cam. So I'm going to use this, right? So let's click on the new space cam. So now I have this window. I can just create the geometry. Okay, let's go on sketch, already on sketch, and I click here the circle and I can come here in the middle and I draw my circle. I'm going to assign it. So the dimension. So my let's say my circle is around, let's say 1 meter of radius. So I can put 1 meter, but it's on millimeter. So 1 meter is 1,000 millimeter, but here is the diameter. So 1 meter is the radius. So it's 20 meter. No, it need to be two meter as the diameter. So 2,000 here, 2,000. So this is the diameter, 2,000. So now I can go here on design and I take pull. And yeah, but if I do this, I can see that here it's full. This is not what I want. Okay. So yeah. So let's go back here. Let's go back. Now let's draw another circle here and circle. Yeah, so whatever. Here, the thickness of the circle, I'm going to assign it later. So I'm going to show you. So first, let's go on design here, pull, and now I can have my cylinder. So I need to assign the length. So the length is 10 meter, which is 10,000 millimeter. Okay, so this is 10,000 millimeter. So what I would do is, because I want to work with shell elements, not solid. So two dimensions, I mean surface, that's what I want to have. So let's go on prepper, mid surface, you click it one time, and then you go other side, you click it two times here. So now as I have it on blue color, you click here, and now you have it. Let's check here if we can put the thickness. Yeah, we can. So let's right click or maybe go down here, thickness. So now time to put the thickness. So the thickness is 1 millimeter, okay? 1 millimeter. And now, okay, which is fine. We already put 1 millimeter. So now the geometry is finished. I have my shell, cylinder, which is in shell elements. So this is really fun because the mesh is going to be faster and the results are going to be very accurate because the mesh will be very, very good. So now let's close here and go on the setup. So now let's go here. Either you click on model or setup is the same thing. So now I can see my model here. This is my cylinder. I can click on coordinate system so I can see the origin here. You click the pan and you can move it. Yeah, and you can zoom in and zoom out with your mouse. Yeah, so let's go on unit here because I prefer working on millimeter here. Millimeter, kilogram, Newton, etc. This is what I like. So now I can go here on geometry. You click the mid surface. You can even come here on thickness and put what you want. Okay, but let's keep it up with the one because that's what I want. Let's go directly on materials. Material is structural steel. So this is what I want as well. If you want to change, you need to change it way before or in the workbench. There is properties. You can assign it and put. But if you guys want to know how to manage the properties, you can ask me below the comments. I can show you how. So mesh, you can generate automatically because this is one of the benefits of having a shell element. Why? Because the geometry, the mesh is really easy. That's why I didn't want to work with solid because solid it can be easy as well because this is symmetry, but with the shell element is fine. It's going to be a great mesh. Let's see, generate mesh, and this is an easier one. Okay, so you can see how you have it. This is not a really good mesh. You can see there is it's deformed. You know, you can go here on mesh. You can come here on the element size. I can put what I want. This is millimeter here. Let's say I want to have 100 millimeter, and let's go and see updates. Let's see what we will have. 100 millimeter. So this is good. Okay, this is a great mesh, but I can see this is really fine mesh, and I can even pull 200. I can see. Yeah, let's go 190 or 180. Yeah, and let's see. Yeah, so this is okay for me. I can just stick with this one, but no. Let's. This is really fine. I don't want to waste too much time when I click on run my analysis because it's going to take some time. So let's go 300. Let's go 300. So it's not going to be a final mesh like this, but it's going to be okay. So this is okay. Okay, so now let's go on model here and right click insert. Let's go on displacement. Okay, where is my displacement? Displacement, because only the translation. Displacement is only for the translation. If you take fixed support, it's going to block everything, but the displacement only for the translations here. So what I want to fix is along the z-axis and the x-axis, the z and the x, but the y no, because my cylinder length is along the y-axis. So let's go on x and put 0. Let's go on the z and put 0, and the y we leave it as free. And now you can take here the edge, because this is some edge, shell elements, you click edge, and now it's fine. So the second thing is just to know what you want to visualize. I want to visualize the deformation, strength, stress, but let's click deformation here, total deformation, and let's go the stress as well, but I think the deformation is what's important here because this is model analysis. So let's go here, model and solve. So it's going to be, yeah. So there is something that we didn't do, maybe on the analysis setting. Okay. So max modes to find, I think 20 is okay for me. Limit search range, no, I don't want it. So let's go here. Solver type, I can have many here. Let's go direct, because direct is going to be very faster, and this is not a complex geometry, so direct is very well. So let's check the other things. Advanced, it's okay. Output controls, so output selection, no. Stress, no, I don't think so. So the nodal forces, let's see here. Error calculator reactions, no, I don't really want it. So yeah, I think this is fine. So let's go here. The stress here, I don't want to see look at the stress. Let's just suppress it, and let's go here. Solve. So now my simulations is over. I can go and look at the results. So let's not forget the goal here is the model, is the natural modes, okay, because this is model analysis. So the natural frequencies is what we want to see. So let's go here, solution, total deformation here. Let's take here. I want to see the table here, okay? So yeah, these are my graphs. So let's click here and see the different types of deformation we have along the frames. So what I want to see is the different modes. So I don't see the table. I need to go here on manage and let's search for it. Tabular data, and let's go. Tabular data is here. So this is my tabular data. Where did I put it? So it's here. So I can see here, you can see the modes. I looked for the 20 natural modes, the first 20 natural modes. So you can see the different frequencies. The first one is zero, the second one is zero as well, and the third one is close to zero or even zero. Why? Because this is considered as a rigid body. Okay, so it's from the fourth one that we start to have real frequencies because it's close to one on the fourth one and the fifth one as well. And from the sixth to the 20 is higher frequencies values that we have. And this is so normal because the first one is very rigid mode. So make no mistake, every single mode here has its type of deformation. You can have torsion, you can have bending, all of that. So let's go here on solution and look at one deformation. For example, directional. And no, let's go the total one because the total is going to give you the total. So yeah, I don't want to look for only one direction. So total, which modes I want to see, let's say the 15th modes or maybe the 10th modes. So this is fine. Okay, the 10th one. So let's evaluate here. And you can see here, you can see the deformation associated with the 10th mode. Okay, you can see. So you have circumferential modes and then you have axial modes. So the circumferential modes are these that you can see. So this is one, two, three, and fourth. So in these modes, you can see you have about one, two, three, fourth circumferential mode. And for the axial modes, you can see only one or maybe two. I can't see normally. I think this is only one, it's one or two. Yeah. So if you guys want to know more about this type of modes, you can ask below. I can do another video about the circumferential modes and the axial modes. So this is what you have for modal analysis. So I can look at another one, but let's stop for here. You just saw how I did. So I hope that helps. If you want some advanced video about modal analysis or other questions, you can ask below. So I hope that helps. Peace.